Now in this video we are going to solve a problem on implicit differentiation. But this problem is quite tricky, so I wanted to watch how I'm going to solve this problem is on implicit differentiation. And I'm going to say something for those who have not watched my previous video. You can go back and watch my videos on implicit differentiation and other differentiation like product, quotient rule, so that I can understand it better. Now I said something, how do you identify an implicit function? It is when you have x and y in such a way that you can't separate x from y. Each time you see a function of such, you just know it is implicit function. Now if you look at this, you can see I have x and y, sine xy is a function of xy, so I cannot separate x, I cannot separate x from y. So when I have a question, an equation like this, I know it is an implicit differentiation. Now let's solve this problem. Now if you look at this, I have, this is two functions as products. So I'm going to deploy product rule. So I can break this down into u and v. Now this is the formula for product rule, u dot the v dx plus v dot du dx. Now if I take this function, u is exponential y, so I'm going to write exponential y dot v, the derivative of v means I'm going to differentiate cos x. If I differentiate cos x, I'm going to get minus sine x. Go back to your standard table. The derivative of cos x will give me minus sine x. Plus, then v is cos x, so I'm going to write cos x dot, I'm going to differentiate u. Now if I differentiate u, I'm going to get exponential y will give me exponential y dot dy dx. Why did I do that? Check my previous video. I said each time you differentiate with respect to y, you always multiply your result by dy dx. So I'll move to then equals to the derivative of a constant is 0. I've said that over and over again in all my videos. Derivative of a constant is 0. So this, now this is sine xy is a function of xy, but this is in form of product. So I'm going to break this down as well into u and v. So I'm going to do product. So this is u, x dot, the derivative of y is 1. Now because I'm differentiating with respect to y, I'm going to multiply my result by the y dx. I'm going to write the y dx here. Then dot sine xy will give me cos xy. So I'm going to have cos xy. Then plus, now this is v is y. I'm going to write y dot, the derivative of x is 1 dot sine xy will give me cos xy. Now I'm going to tidy up this. So this will give me minus exponential y sine x. This is plus exponential y cos x, the y dx, equal, so this will be x cos xy dot the y dx plus, so this will be y cos xy. Now the next thing I'm going to do, because I have the y dx here and the y dx here, so they are like terms, so I need to bring them together. I'll take this to the other side of the equation. So my new expression will be exponential y cos x dot dy dx minus x cos xy dot dy dx equal, so here I have y cos xy, then I'll take this is a negative sign. The moment it crosses the equality, it becomes positive exponential y dot sine x. So therefore, I'm going to factor out the y dx. If I do that, the y dx will be exponential y dot cos x minus x cos xy equal, so I have y cos xy plus exponential y dot sine x. So therefore, I'm going to divide through by this, so the y dx will be y cos xy plus exponential y dot sine x divided by exponential y dot cos x minus x cos cos xy. So that's pretty simple. So this is how to solve a problem. This question looks very tricky, but just understand the rules. That's all you need. Just understand the rules. So this is how to solve a problem like this. Thanks for watching my video. Always subscribe on my channel to get more video. God bless you. Share my links as well. God bless you and bye.